Okay, so we have this question right here. It says two coils P and Q are close to each other. An alternating supply is connected across coil P as shown. The number of turns on coil Q and the separation of coil P and coil Q can be changed. Which row of the table gives the arrangement that produces the largest EMF in the coil Q? So we want the largest EMF. That's our main goal. Okay. So coil in this scenario, coil P is actually creating a lot of magnetic fields. Okay. Like this, and more of these fields. Okay. So let's also write our formula as well. It will help us significantly for this question. So we have EMF negative and D negative D N magnetic flux divided by dt. Okay, so this formula is also given in your formula sheet as well. So now let's check our options as well. Option number A says fewer turns, and if you see the option number C as well, it says more turns. So it can either have more turns or less turns in coil Q. So now if you see the formula here, the number of turn to get a greater EMF, you need to have a lot of turns. If you have less turns, you have less EMF, produce. So option A and option B is incorrect according to this formula. Okay, you can't have a largest EMF with less turns. Okay, so let's check option number C and D's second column. It says either it can be closer or it can be further apart. Okay, let's draw some coils here. Okay, so we have these coils here, and then you have a coil here as well. Okay, so I just drew them further away. Okay, so you have these magnetic fields going around here, here. Just imagine they're going further away as well. Okay, so these magnetic fields, right, if the coil is closer to here, like for example, if the coil is made here, it will have a lot of magnetic fields going through it, which means it will have a greater magnetic flux. Okay, so in other words, you can say magnetic flux is basically the amount of magnetic fields going through this roundy coil, okay, inside these coils or inside these loops. Okay, so if you have this thing greater, magnetic flux greater, then you have a greater EMF again. Okay, if it's further, then it has less excess of magnetic fields, which is bad. Then you have less EMF, right? If you're right here, then you have less magnetic fields, right? And then it means that you have less EMF. So you don't want that. You want greater EMF. So you want it to be closer to each other than further apart. Okay, so your option C satisfies this condition, or basically you can say that the option C helps us give this larger EMF. Okay, so your final answer is option number C. Follow for more.